What?
I think it's still setting up. All right. Hey, welcome to wasmCloud Wednesday. This is the week after KubeCon, so a lot of us are still getting back and catching back up to everything. We had two back-to-back conferences from Wasm.io in Barcelona to KubeCon in London. The wasmCloud maintainers gave lots of different talks, and I'm expecting us today to give a little bit of an update on any talks, any news that happened, all that kind of cool stuff, and yeah, Brooks isn't here, so I don't know. Bring all your dad jokes, just for him in particular. I feel like he's been leveling up his dad joke game, and I don't have it, so I need everybody else to fill in for that for me. But first agenda item. Jonas is going to show off what he demoed at KubeCon, and I think it was a pretty cool demo. And also set some context for that one, Jonas, because I think I don't have the CFP handy for what you submitted.
Sure. Yeah. Do you want me to just take over and then kind of go through it? All right.
Yep,
Awesome.
absolutely.
I'll first kind of just preview the relevant slides from the talk, and then we can talk a little bit about, can you all see my Google Chrome?
Looks good.
Okay. So the talk Colin and I gave was SPIFFE in practice, universal identity for WebAssembly workloads. And the idea is basically that as we work towards introducing a form of workload identity for wasmCloud, the idea was to basically preview what that might look like. And so Colin gave a really great intro and motivation on this in the beginning, talked a little bit about WebAssembly, because of course you have to introduce WebAssembly to a Kubernetes audience. I had kind of revisited already some slides around what are some of the use cases we're looking to bring SPIFFE for, and I should maybe start by just introducing SPIFFE a little bit. So SPIFFE is a standard, and that has been built and implemented inside of the CNCF. So essentially the idea is that SPIFFE gives you a format that allows you to describe identity that is associated with a given workload. And it gives you a couple of different representations for that workload or that standard format that you can represent it in. And so there's a JWT-based representation and an X509 certificate based implementation. And so with those two technologies, there's a whole host of different use cases that we could use this for within wasmCloud. I've listed a few of them here, but already talking to some folks at the conference, we came up with some new ones. And I'm sure that once the tooling is available, the community will come up with ever more use cases, which is exciting. So just to kind of set the stage, what it looks like is we have in this case, for the purposes of the demo, we're running this inside a Kubernetes cluster. We have a Kubernetes node where we have a wasmCloud host and the SPIRE agent. So SPIRE, I should introduce SPIRE is I forget the exact what the letters stand for, but it's essentially the reference implementation for SPIFFE. So it's SPIFFE being the standard, SPIRE is the actual implementation. So it allows you to basically take the standard and actually put it to practice. And so what we're doing is we're using the SPIRE agent and SPIRE server as a way to serve the workload identity and then we're teaching the wasmCloud host and down the line other wasmCloud components to be able to actually fetch those identities and validate them and communicate them to one another. So the problem is that SPIRE was designed, SPIFFE and SPIRE are basically designed for the container age. Now, the thing that we differ, that wasmCloud and WebAssembly, broadly speaking, differs from is that SPIFFE, because of the nature of being introduced in the container age, it expects to basically be able to talk to and observe every single workload that it is issuing the identities for. Now, as you all know, in the case of WebAssembly, you cannot actually observe the WebAssembly workloads that are running inside of a host, in that you can't directly access a PID and see that that's the WebAssembly workload running, right? They're all running in the WebAssembly host workload, or the WebAssembly host runtime host. So that is the crux of the problem. Now, there's a solution for this inside of Spire called Delegated Identity API, and that's actually what the demo is going to be showing you, is the implementation that we brought into wasmCloud host under an experimental flag. So I think that's the, I guess I should just quickly jump in and talk a little bit about the demo application. So for KubeCon, we had a demo application called wasmPay, and the idea is that there's a whole host of components that make up the entirety of the application, but for the purpose of the talk, we are zooming in on this specific bit here. So the API gateway, and I'll kind of zoom in on the next slide. So the API gateway, what it's doing is basically receiving HTTP requests, and it has two special routes, one under API v1/token for minting JWTs, the SPIFFE JWTs, and another route called API/API v1 Bedrock, which it then uses, where you can send the SPIFFE JWT, and the API gateway will exchange the SPIFFE, the JWT, for a token with AWS, a secure credential, a temporary secure credential that the application will then present to Bedrock on the other end. So Bedrock being an LLM that you can use to invoke all sorts of things, operations with. And so what we're asking Bedrock to do in this case is actually write a story about workload identity. So for the purpose of the demo, we're going to be curling the API gateway that's running on a wasmCloud host at these two URLs. And then once we curl it, we'll be able to take the token that we get from the first endpoint, send it to the second endpoint. And as a result, what we expect to get back is a story about workload identity. So let me switch gears, and where is the button? Let me see. Okay. Can you see my terminal? SPIFFE in practice. Yes, no, maybe, hopefully. Okay.
Yes.
I see.
Yes.
All right, thank you. All right. So, because I'm really bad at typing when I'm on stage, I ended up creating a makefile with a whole bunch of commands. The ones that, so I'll first show you what happens when I just call there's basically two endpoints. One of them is getting a token for AWS. Another one was getting a token for just for the talk to show the audience that this is a real thing. Maybe I'll actually skip the KubeCon one because it doesn't really matter. But for the purpose of this demo, what I'm basically doing is I'm sending this curl request to a wasmCloud host that I have running locally, which is running the API gateway component in this case. So I'll send a request to /API v1 token, and then we'll pull out the response. From the response, we'll pull out the JWT SVID, and we'll set it to an environment variable, which will allow us to send it to the Bedrock endpoint. So the second request will actually be using the Bedrock request. Actually, I'll use the Bedrock request print command, which will take the token from the previous call. It'll pass it in as an argument. And then once that token is given to the endpoint, it will exchange it with AWS STS for a AWS specific credential that will then it'll then pass down to Bedrock to use to write the story. So let me kind of illustrate this in practice first. So we'll do make token AWS. And so this is a valid SVID. I'll show you that in just a second in the browser. So I'll just pop this variable in, this environment variable in, and then I can make Bedrock request print. And what we expect to have happen now is for this to respond back with a story about workload identity, assuming everything's working. So all I'm doing is setting this JWT, which has nothing to do with AWS. It's specific to this wasmCloud installation that I have running locally. And what I'm doing is exchanging it for a token specifically for AWS. And if everything works, as it has, we get back this nice story that is made up by AWS Nova Light model about workload identity. So this is all generated without me having any credentials locally to talk to AWS Bedrock. All I have is the Spire, the reference implementation, minting SPIFFE JWTs, and I'm then I have a trust relationship created from this my local Spire installation has a trust relationship with the upstream AWS account to basically say when you receive a JWT from this account, you can exchange that for a set of credentials that are valid for interacting with AWS. So that's kind of the gist of it. Let me see. Where's my cursor? So what I'm going to do now is I'm going to show you one of the, so this is the response. I'll just show you that this is real. Let me just switch back to, let's do the browser, I think. Okay, so I have this site called JWTMS. There's many of these that can unpack these tokens, but if I paste in the token that I got back, what you'll see now is that the subject for this token is wasmCloud.dev, SPIFFE in practice, which is the namespace, and API gateway, which is the component in question. So this is just to indicate that this is the specific wasmCloud component in question running on my cluster that is the subject of this token. And then in this case, I just made up an audience. In the other one, it's actually pointing to an AWS service. But this audience is to basically communicate this is the intended recipient of this token. And with these two, you can basically set rules inside of AWS and other cloud providers and many other services as well to say, when I see these values, it means it's a valid, it is a token that I can exchange for another token to be used within their ecosystem. So without me giving them an actual secret, or these are a form of secret, but these are short-lived. I don't know what the expiration and issue that basically translates to. I think it's maybe it's an hour. I think it is an hour. These could be as low as 5 minutes, and in practice, the AWS side of this is actually reduced to 15 minutes. So the credentials that are minted as a result of these tokens are short-lived. So the nice thing is, like, if one of these were to leak, they would typically have maybe 5 to 15 minutes time to exploit it. After that, it would expire, and it can no longer be used. So the benefit of this is that if you had your credentials leak for some reason in a pull request or otherwise, by the time somebody got to them, they might already be revoked, or rather, they might have already expired. So there's nothing you can do with them. So not that you should leak these tokens, but the point is, like, it allows you to basically automate the process of not having to, rather it makes the process of not having to worry about these things a lot simpler because they get revoked or expired so often that if in practice, if they get leaked, you have a very finite amount of time to exploit them. Unlike normal tokens, which generally are, could be days, weeks, potentially indefinite. Yeah, I think that's the gist of it. Yeah, that was the demo time. The point of this talk was just like, now we have these tokens available to be used within WebAssembly because the functionality that we're using in this case is actually served by the host. So the host provides a new interface called wasmCloud Identity. I had that. So we have this new interface, wasmCloud Identity here, that's available from the host as an experimental feature. And through that, you can request these JWT-based SVIDs. Now, there's a lot more work we want to do around this to make it also possible to request the TLS credentials down the line and other configurable things. But this is a starting point to kind of prove out the concept and show what it can do. So yeah, I think that's probably all I wanted to demo there.
Jonas, this is I love this work. This is pretty cool. And from talking to like big orgs like banks over the years, we've constantly seen people have a trouble keeping credentials up to date. Like an app will have a set of static credentials for a quarter or a year, and people are doing these manual processes in order to keep them, their apps secure and the credentials valid. When we're thinking about moving to evergreen credentials, where you're constantly doing this, how does the change control work here to sort of say, like, this app is, how do you revoke then, or how do you admit, maybe I missed that detail there, like to sort of say I have a new app, or we're going to shut this app down to get there?
Sure. Yeah, great question. So the way, so the credentials themselves are set up with short-lived or short time to live. So typically 5 minutes is what you would expect these to live in, but you might have use cases where you might want it to be a little bit longer. So that's the first thing. Is like once those credentials have expired, there's nothing you can do with them. Now, as far as how do you control a given application, whether it's being onboarded or offboarded, you would do that through policy. So you create a trust. There's a trust relationship that you first create between the Spire deployment, and you typically have like a single Spire deployment per cluster. Effectively, they have something called a trust domain, which basically establishes this is the cluster that you're establishing the relationship with. So every cluster would have typically every cluster would have their unique trust domain, which you could think of as kind of like the DNS address for the cluster potentially. So that's you create the relationship there, and then you within the cloud provider or within the service provider, you create policies that are associated with that trust policy. So you say workloads from this, and specifically you say like this specific workload, which is part of the reason why we're representing them as part of the sort of the path. As part of the URL, we represent the path, which is maybe the lattice and the component name. So only this specific workload within this trust domain, within this cluster, will actually have access to this service. And that is something that you'd write as part of the policies that you then set up on the AWS side. So rather than having to create a specific set of credentials that you make available as secrets to the application, you create this trust relationship. And at that point, the workload can request its credentials at any given time, right? And assuming that the trust relationship exists and the policies are in place to allow that workload to talk to something, then it will be allowed to talk to something. But if either one of if the trust relationship doesn't exist, or the policies don't allow for that workload to talk to something, that given service that you're trying to talk to, it will not be able to talk to it, even if it had a valid SVID.
Okay.
Yeah,
Thank you.
I think there's definitely some, once this is really early days, but there definitely are going to be, Bailey, there definitely is going to have to be some sort of a dashboard, or we use existing CRDs if we're going to be really in the Kubernetes world. We could, for instance, like Istio and various vendors already have, ways that you can map what can talk to what and things like that. I mean, there's a lot, but yeah, then we will have to make that's kind of the next phase, is the user experience part. Yeah.
My question was kind of along that same vein. How much did you have to do that was specific to Bedrock and AWS? And could you do it for other cloud services in a different cloud and different types of services?
Yeah, great question. So there's nothing specific to Bedrock. All I had to do is essentially, and this is a standard part of the OIDC identity provider that you can set up with AWS. So what's happening in the background? And I didn't go into this because it's kind of AWS specific details. But in the case of AWS, what you do is when you take the JWT SVID, you invoke the STS assume role with web identity endpoint, or the method. And what that does is you basically present a token that you then AWS then checks against one of the pre-provisioned OIDC identity providers. So you have to set up the OIDC provider relationship inside of AWS.
And you're assuming an IAM role.
Correct.
That's
so
what the assume call makes. Yeah.
Yeah. So you're assuming into a role within AWS, which means you can apply all the AWS policies into that role. And so from there, it's like it's just like you had AWS credentials stored, except you don't have AWS credentials stored. You're only assuming into a role, and then all the AWS primitives apply. And this would translate to any cloud provider just the same. They all have the same, more or less the same primitives in place, just slightly different language. An increasing number of service providers, like a good example, I think Confluent has added the ability for you to actually authenticate into Kafka to talk to their Kafka services using these same primitives. So it's becoming commonplace to be able to establish these through a policy relationship, basically.
So I think in summary, though, like from a business perspective, there's two big problems that are solved here. The first is let's talk about first and third party multi-tenancy in a single cloud. This lets me take the same component and run it in as different users, for example, and then get the right credentials at the right time for that particular user that's locked down just to the resources that they're supposed to access, correct? And then the second huge thing that this solves for me is if I have a single component and I want to run it across 3 different cloud providers, when I take that component to AWS or to Azure or to on-prem or wherever that case is, this lets me get the right, IAM, the right STS, the right security and secrets that I need for that contextual deployment as I move around. This is awesome. And this is like the authentication Rosetta Stone for us with WebAssembly components.
Yeah. And I would add to that, I think the important thing is this is not dependent on like the place where you run it. This is running on my laptop talking to AWS. We had it in the demo running on AWS talking to AWS, but it could have been running anywhere. And it has, as long as it has the ability to make the HTTP calls to talk to the AWS endpoints, it can assume those roles just the same. So it's really nice to be able to like move your workloads around as long as they have the trust relationship in place. Sorry, they can exchange for the tokens they needed in order to interact with the services they want to interact with. So that's pretty nifty.
And just to add on too, this is how OIDCs are meant to be used, right? This isn't a hack, right? This is exactly what AWS had in mind when they allowed a third-party OIDC.
Yeah. There's a lot more that we could do. Like this is one of the use cases, but there's many more that this allows us to do, even within the wasmCloud ecosystem itself in the future. So this is just an illustration of what's possible once you have the workload identity as a concept in available to you, but certainly not we're not limited to this. Like we'd like to be able to do things like pull OCI artifacts using these same set of credentials, be able to mutually authenticate between services running inside of wasmCloud, things like that. So there's a lot of opportunity for what this can be used for. It's just that I think this was the most sort of one of the flashier things to demonstrate, because it's sometimes like, oh yeah, things just keep working the same way. It's like, yeah, but the difference is now you don't have secrets in the mix, which is really important because you don't want secrets leaking if you can help it. So anyway.
Awesome. Thank you, Jonas. Any questions for Jonas or Colin? Cool. Kudos. All right. So that was technically our only agenda item for today. We are still getting back from conferencing. We were just talking before we turned on the recording about some of our favorite talks that we saw that I think are worth checking out. In the wasmCloud Slack, I see Aditya already linked to Luke's talk. I'll drop that, or if somebody can drop that in the chat here. That is definitely what we consider one of the must-watches of the Wasm.io conference. The other one is that the Oracle engineers talked about how they've been working for the past 1.5 years on adding Java to Wasm compilation support to the GraalVM, which is really, really exciting. And they showed it working with GraalVM Enterprise with the plans to open source it soon. And so I think that one, when it's up, we'll definitely post in the wasmCloud Slack. I think that's another absolute must watch. And I can't actually say that me and Liam's talk was a must watch, but it was a fun one. Lots of demos, and then Liam gave a V2 of that at KubeCon. You want to talk about that, Liam?
Sure. I gave a talk that tried to really tell the platform engineering story for WebAssembly components. I spent the first 10 minutes going through what I felt were the 5 big failures of even highly optimized containers via demo, which I got through my demos. They all worked live on stage, which is great. And then I went through and sort of demonstrated how WebAssembly components work to solve those. I really enjoyed giving the talk. It was one of the talks I spent a long time sort of building up and working through like that many live demos on stage. So I think it went pretty well. And we'll link it out into wasmCloud Slack as soon as they come in. Yeah, I mean, I think that across the team we had 7 talks, and we had 3 talk on Thursday. We had 3 talks at the same time, which was hard because we also had 2 booths to cover at KubeCon. So both the Cosmonic booth and the wasmCloud booth. So we had I would say, an exhausting trip. If we seem especially wiped out from this last trip, it was just 2 weeks of nonstop, all day WebAssembly for us. So. I know Bailey, Jonas, and I were there and just completely wiped out afterwards. So,
and Colin and Brooks. Go ahead, Colin.
Sorry. Yeah. Yeah, because thanks, Bailey, on the wasmIO talk. Yeah, I gave a wasmIO talk too. And it was really about trying to make an actual component and the real world struggles or where we still need to kind of make some improvements in WIT and WASI. Nothing that I think that people didn't know about, but yeah, I made it with the content authenticity C2PA SDK. Made a component for that, defined the interfaces. The only thing that was actually that was a little bit tricky was callbacks, where we don't have those yet in WIT, but I think we're going to have them for 1.0 for the release candidate, hopefully. You can do it. You can go. There is a way to get something like a callback in, but it's a little involved. It involves making a special component just for that callback. But yeah, that'll be hopefully out also on YouTube at some point, like all of ours.
Yeah, so we'll get all those links linked out on the wasmCloud Slack, and we should probably do like a blog breakdown. In terms of cool conversations that I had at the wasmCloud booth, I think I really enjoyed people knowing what WASI P2 was and asking like really specific questions. Over the years, it usually started as what is WebAssembly? And then it became, like, okay, how do I apply WebAssembly to backend services? And now it's like, real deep technical questions, which is pretty exciting. I think the conversation that I had with Florian about workload identity was really cool. He's got ideas about doing mutual TLS between components, doing a component to component call where the component themselves can assert that this is a real identity that they want to interact with. That was awesome. I got more to figure out there and learn, but I think that was really good. And Colin, you staffed the wasmCloud booth a ton. Did you have any combos worth calling out to the community?
Probably should have, if I had thought before, maybe. Yeah, I would say people were much more receptive. I think in general, I don't know. Shoot, I'm sorry, Bailey. I can't think of anything. I
Sorry for
remember
Jones
Brooks
spotting
definitely
it.
had some quotes he was listening to, and he definitely wrote down some of my quotes as usual whenever he interacts with me. But I don't know if I had any super special. I think, yeah, I don't know.
Yeah, I think, sometimes people ask me if this was the year of WASM. I'm like, absolutely, every year is the year of WASM. Uh, but, seeing real stuff being built on top of WASI PGs felt really good. Where people have seen it and tried some things and maybe found some rough edges. But if you're getting far enough that you're hitting rough edges, that's a really good sign. So, anyways. Yeah, I had a great time. Happy to be back too. Brooks will be back next week, and I'm expecting us to run through a roadmap. Masood, I think you said you had a question about WASI right now. Do you want to run through that?
Yeah, it's about I think of course, WASI is not the first one encountering it. I'm just thinking about what people think about this. Those version mismatches when, uh, especially when foundational, interfaces, such as what we saw with I/O, is changing, which has a ripple effect across the ones that are using, let's say, socket and this and that, and suddenly you find yourself in matching this tiny version to that tiny, and that's very difficult when you're trying to kind of manage the system. And as the ecosystem grows, obviously this becomes a more kind of acute problem. And I wanted to know that what are the thoughts around kind of countering and containing this issue?
Yeah, I can share a few. The first one is that we're working really hard to get rid of WASI-IO completely by what we call it canonicalizing, but essentially representing a lot of the APIs that are inside WASI-IO today at the component model ABI level. And that's part of the WASI P3 work to asynchify all the things. And so that really vastly reduces the blast radius of WASI-IO. That's the one set, if folks aren't familiar, where you interact with the stream and pullable interface. And then essentially, most other WASI APIs themselves are some form of IO, whether it's interacting with the socket or a file system or HTTP. And because it brings in, the concept of a stream, then it's bringing in WASI-IO types. So the blast radius of applying WASI-IO and making changes there is broad and can be complicated. So step one is actually making it so that those types are just part of the component model ABI, and those types aren't changing. They're not getting new versions. It's just the ABI that is supported. So that step one will make a big difference for at least that specific set. Now, if we're talking about, let's say I'm going to make up an API. One that we've talked about before, but isn't a real thing, would be URI. And having a type of URI that we have different ways of breaking up a URL and getting the origin, getting the port, all that kind of stuff. So you may rev that API some, but probably not a lot, right? Like at the end of the day, that's something that's going to be relatively stable. So in those scenarios, even though it might be applied to many different WASI packages, some of the ideas there is that because we can look at APIs and know exactly what is actually being used, you can support forwards and backwards compatibility at the runtime level. I haven't actually seen that applied super well in practice, however. I think that's one of those things where the ecosystem itself needs to have some level of maturity around the tooling to be able to sufficiently support that. Right now, a lot of that tends to be a little bit more hard-coded. However, it's totally possible. And I think by having forwards and backwards compatibility, you can really make this a much better ecosystem than even, other dependency type solutions. That's the first part of it. I guess the second part is, WASI right now is kind of treated as a monolith, and we're aiming to make that more of a modular thing after 1.0 once we reach stability. I hope that answered your question, Masood.
No, actually, the part that at least some level of basic support for backward and forward compatibility built into the entire, let's say, framework or specification would be great news, right? Especially after, those tags being introduced, such as since and those things that they say when something is deprecated and when something was added to an interface, and then it becomes like a nightmare if you try to manage that manually, right? Of course, those foundational ones, it's great that they go to ABI because that's going to address a broad range of such issues, but still it remains that, for example, if we go to the next version of messaging, we still need to observe some of that and so on and so forth.
Yeah, I'll link out in the wasmCloud Slack after this to where Wasm Time has the forwards and backwards compatibility built in. But that's not currently in a shared crate that other ecosystem tools use. And I think effectively what we really want is to smooth out some of the things that like Colin experienced when he was building his demo with WStud, where it's pinned to a specific version in crates, and essentially the rest ecosystem right now doesn't natively know about the WASI versions that are being brought in, and it could have that like same kind of logic that Wasm Time has for forward and backward compatibility and apply it at the way that it manages it at the crates level and what gets produced at the WASI target. And Joshua is the one that's been thinking through some of the implementation for that. And that's obviously specific to one language ecosystem, but is something that I think could be broadly applied. George, you've got a question?
Yeah. I wanted to ask you that the recommended way to deploy wasmCloud in Kubernetes is through Helm chart, but there's little examples of deploying wasmCloud using gateways to communicate two or more cluster of NATs. And I don't know how to do it and to deploy it. And if someone can recommend me how to config, how to create the configuration to deploy it.
Yeah, I'm not aware of some easy to follow resources for that. Essentially, the way that our Helm platform chart gets deployed, which again, shout out to Masood for building that for us. Thank you. That is the recommended way to deploy. It pulls in the upstream NATS chart, and there's a lot of configuration settings that you would essentially select for the way that you configure your NATS deployment. And then a part of that would then also be how you configure wasmCloud to pull in NATS. But I think largely to answer your question for this one, it is at the sort of the NATS level. I'm gonna pass it to Masood because that's not something I've built myself.
Yeah, so the Helm chart is using literally the Helm native ways of packaging the components and their dependencies. And that means that your subchart is exactly a Helm subchart. And that means that if the configuration that you want to do is available in the main Helm chart of that product, being NATS or anything else, then you can also do it here. If it's not possible there, you cannot, because here all you do is just nesting. Otherwise, the entire configuration is the same. So what you're trying to do, you have to first look into, can we do it in Helm chart of the NATS today? And if you can literally, like, of course, it's changing names or whatever that might be, or IPs, and then you can just take that and put it here and use it.
Okay, so.
And if you have any issues, you can of course reach out to me, and I would, I might answer you with delays, but I can help you figure out what to do. But again, you need to verify that what you want, what you're trying to achieve is possible in NAT chart today. If it isn't, you can't just kind of shove it into something else because NATS is being a subchart.
Okay, and I wanted to ask about how you can expose the NATS chart in order to communicate with another chart in another Kubernetes, because I've been testing the chart of the wasmCloud platform, and
you can easily do that. Let me tell you how, right?
Okay.
Is that simple. Like it's like cargo new or something like that. In that,
Yeah.
you can just create a local chart with a couple of CLI commands and then put those two charts as subcharts of that. And then the variables could be exchanged between those charts, and you have what you're trying to do.
Mm-hmm.
You can ping me on Slack and I put some wording around this.
Okay. And I wanted to ask about wasmCloud in general. it's Wasm is an amazing technology that you're building, and but there's little like documentation and knowledge about it, but I think it's amazing, and I don't understand how if in the future is going to explode or something to I don't know if someone could tell me if you think it's going to become very popular.
Well, I'll give you my very biased answer first, and then I welcome everybody else to join in. I definitely believe that we're going to see exponential growth over the next year. And we are seeing it. If you look at dev stats, where CNCF projects show they're all open, you can go look at the dashboard on number of contributors, folks that are downloading the project and getting their hands on it, and you can see that we have just an amazing amount of community growth. I think you'll also find we have a really wonderful and welcoming community here. Weekly community call. Our Slack's very active, and it's got awesome maintainers like Masood that'll jump on and help solve problems. I think at the end of the day, any given technology is successful largely because of its community, and nothing else matters. And so I think we have a lot of the indicators here that we're shaping up to take off. I think one of the reasons why it's been slow is that WebAssembly itself has been really challenging as a technology to work with. It's been an emerging technology for a while that's got some rough edges. Until WASI P2, really, it was very difficult to do a lot of the kind of basic things and the tooling in terms of what types of things that you could write and the types of programs that you can build. I held that vote last year, January 24th, and that was holding that vote advanced the spec, but really it took almost 6 months to get that new specification being used in standard language tooling, starting in Rust and then Go and others. So you're really only looking at maybe 5 months of just like a whole new paradigm really getting to the point where it could be applied generally. So I think a lot of this is getting way better. And yeah, I welcome anybody else to chime in.
Okay, thank you. I expect it grows and it becomes popular. So thank you all, guys.
Yeah, I think the shared everything functions, once that is done, and it's a lot of work, is going to really make it a lot easier for people to use WebAssembly in the browser, where the tool chains are it's a little more mature because it's been around longer. But I think it's really going to open things up. People are going to be able to just use packages that they expect to just work in their C++ and Swift, things like that. We're gonna have Java, right? So Python, things like that, where we're like, oh, I need a thread, or I have a test framework, or things like that. These things that are hard to get working currently are gonna be a lot easier to get working, and then I think you'll see the barrier come down quite a bit. So that's hopefully going to be within the next year. So that's going to be a big deal.
Masood, your hand's raised.
Yeah, I just want to kind of wrap up that question that I asked on the chat about, making CLI calls. I know that on Wasm time I can, but I also know that some of there are some more restrictions being applied on the wasmCloud, and I'm not sure. And instead of trying to write a component and figuring out the hard way, I thought that I would ask the question here and see, can components on wasmCloud make CLI calls or command line calls, basically? Right?
Yeah, right now, there's no like process fork in the WASI spec. So there's no way to like execute a shell call. But if you compile a component to the WASI CLI interface, and then you run the run function on that, that does work. And that's something actually that I had built out on one of the demos for the conferences. I can't even remember which one now, but I did, in the last 2 weeks, try that out. However, we haven't implemented all of the interfaces that are wrapped up into that, mainly because we hadn't set up a good way to virtualize it beyond asking folks to use WASI-BERT, which was one of the other demos that we did. So file system is one of those where you can run a WASM time and pass in a pre-opened dir, and then effectively when the component runs, it will read from a file. Actually, if you'd like an example of that, let me point you to Liam's repo. And so if you virtualize the file system that you're trying to use using the setup that we did there, you can do a WASI CLI run that then runs in wasmCloud and uses a virtual file system rather than
That's good. I know that when you do a virtual file system, you also restrict access. That's why I wanted to kind of understand that what that means. That means that like no process calls could be made out of that, or it just means that that's where you can write. You know what I mean? Like you have access to modify.
Oh, sorry. It's an in-memory file system. So if you need to make writes and reads, you can. And it's just an in-memory. It's just like think of like a virtual.
What I mean is that let's say I want to make a call to the NATS CLI command tool, right? That's what I mean when I'm saying that making call to CLI tools, right?
Yeah,
So
no, I don't think you can make calls to CLI tools even in the WASM time version because there's no process fork or exec API.
Yeah. You can compile components to use the CLI interface, but you can't execute a system call on an operating system, just call an arbitrary binary.
Okay, because you guys are just back from the conference, I'll let you kind of recuperate, and then I send you the link.
Cool. Yeah, I'm interested. I mean, right now, what you're trying to do to me sounds like something that could be provided by a provider.
Right, and that's really what I'm asking myself. Am I going to waste my time trying to write a provider to achieve this if a component can do this? You know what I mean? And that's exactly the reason that I'm asking.
I mean, I think at some point we did do a YOLO provider that would just take like an arbitrary CLI command and just execute it, as data. I'm not sure that that's necessarily the greatest idea. And, I think that, you can decide like what's the right approach. I think one of the things that we're trying to do with, WASI is, make sure that you do have highly structured inputs and outputs so that you can maintain the composability, the security sandbox, and these other things. And so I think the idea of trying to like poke a hole in that sort of defeats some of the longer range goals of what we're trying to achieve here. But I can imagine the need for it.
So Liam, as you know, still, no matter what the platform, escape hatches should be there because there will be cases that you need to. WASI-BERT is a good way of looking at it, but by the virtue of that, I want to have a flag that I, let's say, explicitly turn on. And I thought that we're doing that through the with interfaces. Like I'm intentionally saying that I accept the risk of interacting with, let's say, a foreign environment.
Well, I think there's a little bit of a distinction between like setting up a system where we restrict things and having, which is, like definitely good design principle, but there's also just the fact that if you're calling you seem to be like trying to call a something not compiled to WebAssembly from WebAssembly, and that's literally what providers are. So I don't think there's anything keeping you from doing this. I mean, it can't execute in a WebAssembly runtime if it's not filed for WebAssembly, right? So it's just yeah.
So I'm wondering from the point of view of why isn't a CLI just another let's say function call? I mean, it could be generic in terms of just whatever policies you want to have around it to protect yourself or to open it up.
So
Yeah, Frank,
you talk about a
that's how I would
CLI,
do it.
yeah.
Essentially, I would create my own custom interface for the type of CLI that I'm wanting to execute and call and manage. So for every effectively process that I would want to call, I would want to create an interface for it because it's really a capability. I'm saying you're allowed to call the NATS CLI. And here's the parameters for that, as structured arguments that are real, with interfaces. And then I would have a provider that ran and executed that command.
This
There's nothing. Oh.
This makes me think of like we've talked a couple times, Bailey, about doing like a Twitch stream or something like that where we would just co-build something like this, or mock it up. Maybe this is something we just mock up real fast together, like I think that would be a fun way to like do an office hours kind of thing, or we could just take some requests and maybe this would be something we could just whiteboard out tomorrow and check in somewhere so that the community could build on it. So I see a lot of positive reactions there.
And if also too, if the NATS CLI itself can be compiled to WebAssembly, then we're in a different ballgame too. Right. Now you actually you would be able to just call out to it.
Yeah,
either
I
through
would
a
want
WIT
to
interface
know.
or into you could compile it all into your WebAssembly component that you want, right? And then you'd have to make sure it also had the IO, the sockets. But yeah, I mean, you could do that. Like, I think that's where we want to eventually get to is like you can compile most things to WebAssembly. It doesn't mean it's a good idea to compile things to WebAssembly, but we do want, we want people to at least be able to make mistakes and compile really huge things that they don't actually want to be in WebAssembly. So that I just don't want people to just try and give up. And I think we're getting there. We're getting really close with the threading stuff, like Tokyo, right? That's my big thing. Once Tokyo just works without a fork, I know we're going to be really close.
Yeah, that's a great point, Colin. So just to summarize, like you could compile the CLI to a component, compose that with your component, so you have a WIT interface that defines the CLI that you're trying to call, basically. You compose with that with a version of that and execute. That should work, and that would be pretty sweet. Yes. Sorry, Masood?
No, I was agreeing that I am waiting for that WASI P3 because I want to think badly for a lot of things. And no, this is not a good way. We should not attempt to reinvent the world just because we're in WebAssembly and say that let's recompile everything and rebuild it in Wasm. I mean, still for something to grow, it needs to integrate with the rest of the world, right? And continue supporting it and improving it and hopefully then replacing it with something better. I mean, WebAssembly and WASI in particular has put a high bar for people to enter. We have to recognize that, right? You have to rewrite a lot of things. You have to have providers as an example, right? So that means that we are asking for that improvements to make some compromises and sacrifices. And we have to know where that boundary is. That people might say that, you know what, if the cost of operationalizing this, outweighs the cost of migrating or the benefits, literally, the ROI question, right? Then we would not have that kind of embracement that everybody in the community expects. I have to jump on a meeting. Unfortunately, this is a very sweet conversation.
Yeah, I love it. It's near and dear. It's one of those that I have to debate all the time, but I know we're at the top of the hour, and I agree completely. We're getting really close to things just compile TM, and that's part of it. But I would say the line to hold and never give up on is that what you build supports capability-driven security models. Otherwise, what's the point of what we're doing? And so long as we can hold that line and we can build out, yeah, I think make things work so that we can build a better future that everybody can actually jump on and be part of the ecosystem.